Good morning, dear students. In previous class, we have discussed about the types of random variable. Now, what are the types of random variable? That is discrete and continuous random variable, right? And we have also discussed about the mean variance and standard deviation of that discrete random variable and continuous random variable, right? Now, here, in the case of discrete random variable, what is the PDF, that is probability density function we have observed? First condition is probability of each element which is always positive, that is P of xi is always greater than or equal to 0. And what is the second condition? Summation of P of xi which is equal to 1. What is meant by this I? I takes the value from 1, 2, 3, 4. Suppose there are 4 values x1, x2, x3 and x4, and there is probability of each function, that is p of x1, p of x2 and so on. If you add, you should get answer equal to 1. Okay, if these two conditions satisfies, then only we can say that the given function is probability density function. Now similarly, we have discussed the case of continuous random variable. Instead of p of xi, we have taken f of x. First condition is f of x greater than or equal to 0. Second condition is integration f of x dx in limits from minus infinity to infinity equal to 1. Here for discrete random variable summation, for continuous random variable integration, right? And what is mean of discrete random variable? Mu equal to e of x, which is equal to summation x into p of x, right? Now, for the continuous random variable, what is mu? That is equal to e of x, which is nothing but integration of x into f of x dx or x into px dx. Whatever the probability function they will give, you have to take that. But here limits from minus infinity to infinity. And what is variance? Variance is capital V or V of x or sigma square, which is equal to what? E of x square minus E of x whole square. What is meant by E of x square? Expectation of x square. See, we have already discussed mean means expectation of x, that is summation x px for discrete random variable. Similarly, you have to find E of x square is summation x square p of x. And E of x whole square is nothing but what? Mean only, that is mu square. And what is meant by standard deviation? Standard deviation is nothing but square root of variance, that is sigma equal to root of V. Similarly, in the case of continuous random variable, here sigma square is nothing but E of x square minus E of x whole square, but here E of x square is nothing but integration x square px dx or x square f of x dx, limits from minus infinity to infinity. And what is E of x? That is mu only. Okay, be careful, here E of x square is totally different from E of x whole square. This is mean square, this is expectation of x square. And again here what is standard deviation? Sigma equal to square root of V. Okay, now let us discuss one by one. Here there are two types of random variables. One is discrete random variable, another one is continuous random variable. We have already discussed about mean variance and standard deviation of both the random variables. Now, what are the types of discrete random variable? First, we discuss with that. There are two types of distribution. One is binomial distribution and another one is Poisson distribution. Okay. Now, here you have to remember this chart, then it will be easy to solve the problems. Here in this new syllabus, they have removed the derivation of all these mean, variance, standard deviation for both the distribution. So just you need to remember the table of this. Okay. What is function or probability function is what for binomial distribution? That is P of x equal to NCX P power x q power n minus x. Okay, let us discuss this expression later. First you need to remember the chart. Probability function for binomial distribution is NCX P power x q power n minus x. For Poisson distribution, P of x is nothing but e power minus m m power x divided by x factorial. Here what is meant by m? M is nothing but mean. Okay. Now what is mean? M is nothing but NP, mean only. This is the extension of binomial distribution. Poisson distribution is an extension of an binomial distribution. Now here mean of binomial distribution is mu equal to NP. Variance of binomial distribution is V of x or sigma square equal to NPQ. And what is standard deviation of this? Standard deviation is nothing but square root of variance, that is sigma equal to root NPQ. Okay. Now what is mean of Poisson distribution? Mu equal to m. Variance also sigma square equal to m, and standard deviation equal to root m. Here mean and variance are same in the case of Poisson distribution, that you have to remember. And what is meant by m? M is nothing but mean is nothing but NP. This only we are using here. Okay. Now let us only concentrate on binomial distribution. Now actually we got this binomial distribution concept from Bernoulli trial. Okay. What is meant by Bernoulli trial? A trial having only two outcomes, say probability of success and probability of failure. Normally we are denoting this success by small p and failure by q. But you have to remember one thing, if you add probability of success and failure, you will get answer equal to 1. Okay. Now let p be the probability of success and q be the probability of failure in each trial. Then p plus q equal to 1. Okay. Now binomial distribution. If a Bernoulli trial is conducted n times, then the probability of x successes in n trial is given by what? Since it is connected to binomial theorem, this can be written in the form ncx p power x q power n minus x. Okay. And the distribution what? X comma ncx p power x q power n minus x is called binomial distribution, or you can write in general x comma px. Px is nothing but ncx p power x q power n minus x. This one we have already discussed in the previous chart. Now what is mean variance of binomial distribution? Mean variance and standard deviation. Mean mu equal to np, variance v equal to npq, and standard deviation sigma equal to root npq. So you have to remember this definition or previous chart. It is left to you. Problems are very simple. Now let us go to one by one problem. Now first problem. The probability that a pen manufactured by a factory be defective is 1 by 10. If 12 such pens are manufactured, what is the probability that, first case, exactly 2 are defective, second case, at least 2 are defective, third case, none of them are defective? See, first you have to try to understand the problem. What is given? Probability of success, small p, is what? Probability of failure, small q, is what? How many items or how many number of items, like that, n you have to find. Okay. Once again, see, the probability that a pen manufactured by a factory be defective is, okay, 1 by 10. And 12 such pens are manufactured, that means n equal to 12 given. What is the probability that, first case, exactly 2 are defective, and at least 2 are defective, and none of them are defective? Here our intention is to first choose x. What is meant by x? Okay. Now let us take probability of defective pen p, small p, equal to 1 by 10. That is what? 0.1. And we know already p plus q equal to 1 or q equal to 1 minus p, right? So what is probability of non-defective pen? Defective pen p equal to 0.1. So what is non-defective? Q. That is 1 minus 0.1, that is 0.9. If you add, you should get 1 because p plus q equal to 1. And what is n given? Number of pens. N equal to number of pens, that is n equal to 12. And we have to write one sentence here, let x denotes the number of pens are defective, so that it is easy to take the condition one by one. Okay, let x denotes the number of defective item. What is P of x? We have already discussed probability function for binomial distribution. P of x equal to ncx p power x q power n minus x. Right? What is n here? 12. And what is x? Number of defective items. Okay. Now let us discuss first case. What they given? Probability of exactly 2 are defective. That means what? When x equal to 2, what is the probability? Rest all we know. P equal to 0.1 we know. Q equal to 0.9 we know. N equal to 12 also known quantity. Now we need to find P of x equal to 2. What is x represent? The number of defective pens. Okay, first case. Probability of exactly 2 defective. That means P of x equal to 2. Put x equal to 2 in this. N equal to 12. P equal to 0.1. Q equal to 0.9. So what you will get? 12C2 into 0.1 power 2 into 0.9 power 10. Now simplify this, you will get 0.2301. Okay. Now second condition. Probability of at least 2 pens are defective. See, what is at least 2 pens? At least means what? 2 or more than 2, up to where it ends, up to 12 pens. Maximum number is 12 here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to that you have to calculate. But it is very lengthy procedure. So to avoid that, you can apply this definition. See, probability of at least 2 defective means what? 1 minus probability of x equal to 0 plus x equal to 1. Why we are taking like this? Because of the definition of probability, what it states, p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 plus up to last value p of x equal to 12, which is equal to 1, right? But instead of calculating from probability from p of x equal to 2 to 12, it is easy to calculate. 1 minus p of x equal to 0 plus p of x equal to 1. That is what? 1 minus. Here you should put bracket properly, and this is sum. Be careful. So what is x equal to 0? P of x equal to 0 means what? 12 c. N is fixed, p is fixed, q is fixed. Only x varies. 12 c 0, 0.1 power 0, 0.9 power 12. 12 minus 0 because n minus 0, right? Plus, similarly, what is p of x equal to 1? 12c1, 0.1 power 1, 0.9 power 12 minus 1, that is 11. So if you calculate this, you will get 0.341. Use the calculator properly for the calculation part. And what is third condition given? None of them are defective. That means x equal to 0. None of them. No defective items at all. Because we have taken x as a defective item, it is none means x equal to 0. So what is probability of no defective item or none of them are defective? Which is equal to p of x equal to 0, that is 12c0, 0.1 power 0 into 0.9 power 12 minus 0, that is 0.9 power 12, which is equal to 0.2824. This is the final answer, right? Now let us move to the next example. The chance that a bomb dropped from an airplane will strike a target is 0.4. Okay, say while reading the question itself, you have to identify what is P, what is Q, what is N. If you identify P, you can easily write Q because 1 minus P is Q. Okay, 6 bombs are dropped. That means N equal to 6, P equal to 0.4, right? Dropped from the airplane. Find the probability that first case exactly 2 bombs strike the target. Second case at least one strikes the target. Third case none of the bombs hits the target. Again it is similar problem. See here P equal to what? Probability of success. That means bomb dropped from the airplane will strike the target. So that is P equal to 0.4. So you know P. So what is Q? 1 minus P, that is 0.4, right? And N equal to how much bombs here? How many bombs given? 6 bombs. Now let X denotes what? Probability of bomb strike the target. You have to choose, let X represent the probability of bomb strikes the target. First case, what is given? exactly 2 bombs hits the target. First you have to write what is the formula. NCX p power x q power n minus x. What is n here? 6. What is p here? 0.4. Q is 0.6. First you apply that in the standard formula. You will get 6cx 0.4 power x 0.6 power 6 minus x. This is the general formula. Here you have to discuss one by one case. First case, what is given? Exactly 2 bombs strike the target. Exactly 2 bomb means x equal to 2. Put p of x equal to 2. That is x represent what here? Bomb hits the target or bomb strikes the target. So what is p of 2? 6c2 0.4 power 2 into 0.6 power 6 minus 2. That is 4. If you simplify, you will get 0.3110. Check it with the help of calculator. Now, second one, at least one strikes the target. See here, again, at least one means one or more than one. That means up to the highest limit. Highest limit what? 6 given. Instead of calculating p of 1, p of 2, p of 3 up to p of 6, you can calculate 1 minus p of 0. Okay? Because p of 0 plus p of 1 plus p of 2 plus up to p of 6, which is equal to 1. Therefore, what is p of x greater than or equal to 1? 1 minus p of 0. Because probability that at least one bomb strike the target, which is nothing but p of x greater than or equal to 1. So what is p of x greater than or equal to 1? 1 minus p of 0. That is 1 minus, what is p of 0? Just replace here instead of x, 0. 6c0, 0.4 power 0, that is 1. 0.6 power 6 minus 0, that is 0.6 power 6. If you simplify, you will get 0.9533. Okay. Last one, none of the bombs hits the target. That means x equal to 0. Suppose the probability that none of the bombs strike the target or hits the target, p of 0. That means 6c0, 0.4 power 0, 0.6 power what? 6 minus 0, which gives us 0.0467, right? This is the final answer for the given condition. Now let us discuss one more problem. If 10% of the rivets produced by a machine are defective, find the probability that out of 12 randomly chosen rivets, first one, exactly 2 will be defective. Second one, at least 2 will be defective. Third one, none will be defective. It is again same as previous only. What is given? 10% of the rivets. That means p equal to 10%. 10% means 10 by 100. That means 0.1. So what is p value? P equal to 0.1. So q equal to what? 1 minus 0.1, that is 0.9. And n equal to how many? N equal to 12. Let x represent what here? Defective item, or x represents rivets are defective. So what is p of x? First you have to write the probability function based on this. N is known, p is known, q is known. X only unknown. X we have to take according to the situation. So what is p of x? General formula 12cx 0.1 power x 0.9 power 12 minus x. What is given first case? Probability of exactly 2 will be defective. That means p of x equal to 2 or p of 2, which is equal to what? 12c2 0.1 power 2 0.9 power 12 minus 2, that is 0.9 power 10, which gives us 0.2301, right? Now what is the next case? At least 2 will be defective. Again you have to remember here, instead of calculating from 2 to 12, you have to take p of x greater than or equal to 2 means 1 minus p of 0 plus p of 1. Here bracket is there, be careful. The probability that at least 2 will be defective means 2 or more than 2, right? That is p of x greater than or equal to 2, which can be calculated with the help of 1 minus p of 0 plus p of 1, which is equal to what? 1 minus, what is p of 0? P of 0 is 12c0 0.1 power 0 0.9 power 12 minus 0. If you solve, you will get 0.2824. And what is p of 1? 12c1 0.1 power 1 0.9 power 12 minus 1, you will get 0.3766. If you simplify, you will get 0.3410, right? Now the probability that none will be defective. None will be defective means what? P of 0, right? Which is equal to, already we have done here, P of 0, 0.2824. Just to calculate, just replace x by 0. You will get 0.2824. Okay. Now next, let us move to another example. Find the binomial probability distribution which has mean 2 and variance 4 by 3. See, here we need to find the probability distribution. They have given mean. Mean means what? NP. For binomial distribution, mean equal to NP. NP equal to 2 given, and variance means what? NPQ. That is given 4 by 3. Now simplify. We know that for the binomial distribution, mean equal to NP and variance equal to NPQ, right? Here, NP equal to 2 given and NPQ equal to 4 by 3 given. Just replace NP value. What is NP here? 2. 2Q equal to 4 by 3, right? 2Q equal to 4 by 3. So what is Q? 4 by 3 divided by 2. That means 2 by 3 you will get. So Q equal to 2 by 3 means what is P? 1 minus Q, right? 1 minus 2 by 3 means 1 by 3. So we know now P, we know Q, we know mean, we know variance. Now we want what? N. What is N? See, already given NP equal to 2. But P is known quantity now because we have already found P equal to 1 by 3. So N by 3 equal to 2. So what is N? This 3 will go to the RHS. So N equal to 6. So what is your binomial distribution function or probability function? P of x equal to NCX P power x Q power n minus x. Just replace all the values. N is 6. 6cx. What is P? 1 by 3 whole power x. And what is Q? Q is what here? We already found 2 by 3. 2 by 3 power n minus 6. Again n is 6. 6 minus x. Right? Sorry, n minus x. 6 minus x. Now we got the probability function. Now you have to find what? Probability distribution table. That means what? When x equal to 0, what we will get? When x equal to 1, what we will get? X equal to 2, what we will get? Up to, we have to continue up to n equal to 6 term, right? Now put x equal to 0, you will get 2 by 3 power 6. X equal to 1, then P of x probability function 6C1, 1 by 3, 2 by 3 power 5. Just to replace x equal to 1, 2, 3, x equal to 0, 1, 2, 3 up to 6. Because 6 minus 6 we will get here power 0, right? Up to that term you have to expand. So what you will get here? 2 by 3 power 6 when x equal to 0. When x equal to 1, 6c1, 1 by 3 into 2 by 3 power 5. When x equal to 2, here px equal to 6c2, 1 by 3 power 2 into 2 by 3 power 4. When x equal to 3, here p of x equal to 6c3 into 1 by 3 power 3 into 2 by 3 power 3. And when x equal to 4, 6c4, 1 by 3 whole power 4 into 2 by 3 power 2. Similarly, when x equal to 5, here px equal to 6c5, 1 by 3 whole power 5 into 2 by 3. Similarly, when x equal to 6, 1 by 3 whole power 6. Just to replace x value 0, 1, 2, 3, 4, 5, 6 in the previous function. Okay. Now, next problem. When a coin is tossed 4 times, find the probability of getting, first one, exactly 1 head, at most 3 heads, at least 2 heads. Okay. What is given here? When a coin is tossed 4 times, that means n equal to 4 given. And we are familiar with the what is probability of getting head or tail, whatever it may be, it is 1 by 2, right? So what is P? P equal to P of H or P of tail. It is left to you. It is what? 1 by 2. P equal to 0.5, even Q equal to 0.5. And N equal to how much? N equal to 4 here. 4 times we are tossing. So what is the probability function here? P of x equal to NCX P power x Q power n minus x. But what is given? exactly one head. So let x represent the probability of getting head. Just you write x represent probability of getting head. Now p of x equal to 1. Just n equal to 4, p equal to 0.5, even q equal to 0.5. X equal to what? For the first case 1. So 4c1 0.5 power 1 into 0.5 power 4 minus 1, that is 3. Now if you simplify, you will get 0.25, right? Now what is given? At most 3 heads, right? At most 3 heads. At most 3 heads means what? Maximum limit is 3. Minimum limit is 0. That means p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3. Up to that we have to calculate. Because p of at most 3 heads means it may take 0 or it may take 1 or it may take 2 or it may take maximum limit 3. So just replace x equal to 0 for this equation and remaining you have to replace 4c 0, 0.5 power 0, 0.5 power 4. Similarly plus for p of x equal to 1 means 4c1 0.5 power 1 into 0.5 power 4 minus 1, that is 3. Next plus 4c2 0.5 power 2, again 0.5 power 2 plus 4c3 0.5 into 0.5 power 3. Now what is common here? 0.5 power 4 common. See here power 0 means 1. 1 into here 0.5 power 4. Again here see if you add the power same. Again here if you add the power same. So 0.5 power 4 is common. Just simplify this. What is 4c0? 1. Plus what is 4c1? 4. Plus what is 4c2? That is 6. Again plus what is 4c3? Again 4. 4 plus 6 plus 4 plus 1, that is 15. 15 into 0.5 power 4, if you solve you will get 0.9375. Okay. Last one. Probability of at least 2 heads. At least 2 heads means what? 1 minus p of 0 plus p of 1. Or else you have to start from what? P of 2 plus p of 3 plus p of 4. It is left to you. Either you can write p of 2 plus p of 3 plus p of 4. That means minimum limit is 2, maximum limit is up to nth term. Nth term is what here? 4. N equal to 4 given. So either you can calculate p of 2 plus p of 3 plus p of 4, or you can calculate 1 minus p of x equal to 0 plus p of x equal to 1. So that is what? 1 minus what is p of x equal to 0? That is 4c0 0.5 power 0 0.5 power 4 minus 0. That is you will get 0.5 power 4. Similarly, p of x equal to 1 means 4c1 0.5 power 1 into 0.5 power 4 minus 1, that is 0.5 power 3. If you simplify, you will get 0.6875. Okay. Now, next move to the next example. See here, a die is thrown 8 times. Find the probability that 3 falls. Okay. First one, exactly 2 times, at least once, at most 7 times. Okay. Say here, in each throw, chance of 3 falls they are asking. Right? Is 1 out of how many? 6. See here, die is thrown 8 times. So n equal to 8 given. Clearly we can observe here. Next, find the probability that 3 falls. That means in a die there are 6 phases, right? Out of 6 phases, here find the probability that 3 falls. The 3 die in a given die, the possibility of appearing the 3. That means what? Only once. 1 by 6. So p equal to 1 by 6. What is q? 1 minus 1 by 6. That is 5 by 6. And what is n? Here given clearly thrown n equal to 8 times. So what is the probability that 3 falls x times in 8th throw? Or you can just write what is the probability function. That's it. P of x equal to what? Ncx p power x q power n minus x. That is what? 8cx 1 by 6 power x 5 by 6 power 8 minus x. Now first case exactly 2 times. What is the meaning? X represent what here? Probability that 3 falls. That's it. So when x equal to 2, so p of 2 equal to what? 8c2 1 by 6 power 2 5 by 6 power 8 minus 2, that is 6. If you simplify, what you will get? See here. 0.2605. Now, the probability that 3 falls at least once, again, at least once means what? You have to start from 1 to 8. Instead of that, you can go for the shortcut method. P of x greater than or equal to 1 means 1 minus P of x equal to 0. Okay, that is 1 minus what you got the PDF here, probability function 8c x. So 8c 0, 1 by 6 power 0, 5 by 6 power 6, because 8 minus 0, that is 8. Now if you simplify, you will get 0.7674. Next, last case, the probability that 3 falls at the most 7 times. At the most 7 times means what? Again, here maximum limit is 7. Minimum limit is 0. So P of 0 plus P of 1 plus up to P of 7 you have to calculate. Instead of that, you can write it in the form of 1 minus P of 8. Because P of 0 to P of 8, if you add, you will get 1, right? Instead of calculating up to 0 to 7, you can calculate 1 minus P of 8. So you will get 1 minus 8c8 by 6 power 8, which is equal to 0.9999, or which is approximately equal to 1. Okay. Now, next move to another sum. See, in sampling a large number of parts manufactured by a company, the mean number of defectives in sample of 20 is 2. Out of 1000 such samples, how many would be expected to contain at least 3 defective parts? Read this question carefully. In sampling a large number of parts manufactured by a company, the mean number of defective in samples of 20. That means n equal to 20, and mean number, that means what? NP, because mean m equal to or mu equal to NP, right? For the case of binomial distribution, they have given NP equal to 2 and they have given n equal to 20. Out of 1000 such samples, see, this is we are working out for only one sample. At the end, we have to check for 1000 samples. Okay, let it be. This part we will discuss later. Now, first you find what is P, what is Q. That is very important, because here we know NP equal to 2, and we know N equal to 20. So, NP equal to 2, 20P equal to 2. So, what is P? 2 by 20 or 1 by 10 or 0.1. So, we got P equal to 0.1. So, what is Q? Q equal to 1 minus P, that is 1 minus 0.1, that is 0.9. Okay, now first mention what is X we are choosing. Let X represent what? The defective item or defective sample. So what is the probability function? P of x equal to NCX, P power x, Q power n minus x, right? Which is equal to what? 20CX, because n equal to 20. And what is P? 0.1 power x into what is Q? 0.9 power 20 minus x. Now, here let us discuss for the 3 defective parts. Here what they given? Out of 1000 such samples, how many would be expected to contain at least 3? At least 3 means what? P of x greater than or equal to 3. 3 to how many times? So 3 plus 4 plus 5 plus up to, we have to continue up to 20. Or instead of that, you can continue with this method. See, P of 3 plus P of 4. Instead of that, 1 minus P of 0 plus P of 1 plus P of 2. So that we will get 1 minus here 0.9 power 20 plus 20C1, 0.1 power 1, 0.9 power 19 plus 20C2, 0.1 power 2, 0.9 power 20 minus 2, that is 18. So which is equal to what? 0.323. So this answer we have obtained only for one sample. But they asked what? The number of defective items in 1000 sample. So what we have to do? For one sample we are getting 0.323. For 1000 such samples, how many possibility of obtaining 3 defective part? That is 1000 into 0.323, which is equal to 323. This is very very important. You have to remember, for one sample you are going to find in the beginning case. Next you have to find it for Whatever number of samples, you have to find it for that. See, similar problem here. In 800 families with 5 children each, how many families would be expected to have 3 boys? Second one, 5 girls. Third case, either 2 or 3 boys. Fourth one, at most 2 girls. By assuming probability of boys and girls are equal. Say, probability of boys and girls are equal. That means equal chance 1 by 2. So P also 1 by 2, Q also 1 by 2. And what they given here? 5 children. So N equal to 5. First you need to find for one family. At the end you have to find it for 800 family by multiplying 800. Okay, that is very important. Now, first write what is probability function Px. That is nothing but NCx P power x Q power n minus x. What is n? N equal to 5. Now, what is P of x? 5cx 1 by 2 power x into 1 by 2 power 5 minus x. Or if you simplify this, here what you will get? 1 by 2 power 5 common, 1 by 2 power c here, 1 by 2 power x here, 1 by 2 power minus x. So minus x plus x get cancelled, right? So that's why 1 by 2 power 5 is nothing but 1 by 32 into 5cx. So this one you can take it as a standard one. Now let us discuss one by one. Let x represent what? Number of families having 3 boys. Having boys, just you calculate. Let x represent boys. What they given here? First case, since we have to find the expected number in respect of 800 families, right? You can multiply in the beginning step also, or you can multiply 800 at the end stage also. It is left to you. First you have to find Px, that is for one family. Now for 800 family means you have to multiply 800 for that Px, right? So 800 into 5cx divided by 32. Or if you simplify 25 into 5cx, you will get. Now, here we are mentioning x represent number of boys in a family. Okay. What they given here? Find the family having 3 boys. So, just replace x by 3. So, what you will get? 25 into 5c3, that is 250. So, 250 families are expecting with 3 boys. Right? Now, next case what they given? Say, the given question, try to understand properly. 5 children, they want 5 here, and we have mentioned x equal to, x represent number of boys, we have mentioned already. Since we have mentioned x equal to 5 boys, so there is no question of girl here, right? So 5 out of 5 children, 5 girls means x equal to 0, because we have mentioned x already as what? Number of boys. So for the second case, what happens? X equal to 0, because here they have asked about girls and we have mentioned x in terms of boys already. So what we will get? F of 0, 25 into 5c0, that is 25 into 1. Now what we will get? Expected number of families with 5 girls is 25. Next, what they asked? Third, either 2 or 3 boys. That means P of 2 plus P of 3. Or means sum, right? And means multiplication, or means sum. So we are finding P of 2 plus P of 3. So what we have to do here? 25 into, see, 25 into 5c2 plus 25 into 5c3, because out of 5 children 2 boys, or out of 5 children 3 boys. Now simplify. What is common here? 25 common, 5c2 plus 5c3, if you simplify you will get at the end 50 into 10, that is 500. At the end you have to write the number of families having 2 or 3 boys is 500. Now last one, what they asked? At most 2 girls. What is the meaning of at most 2 girl? That is nothing but either 0 girl or 1 girl or 2 girls. Maximum is 2 girl. So this can be written in the form of number of boys indirectly, because families can have 5 boys means 0 girl, right? Because only 5 children they have given. Out of 5 children, 5 boys means there is no question of girl, that means 0 girl. Similarly 4 boys means 1 girl. Similarly 3 boys means 2 girl. If you add, you should get the number of kids same. So what you will get? You need to find f of 5 plus f of 4 plus f of 3. That is 25 into 5c5 plus 25 into 5c4 plus 25 into 5C. So 25 keep out. What is 5C5 1? 5C4 is 5 plus 5C3 is 10. Simplify 16 into 25, 400. So 400 families are expecting at most 2 girls. Okay. Now next let us move to the next problem. Say 5 dice were thrown 96 times and the number of times an odd number actually turned out in the experiment is given. Fit a binomial distribution to this data and calculate the expected frequencies. Okay. Now number of dice showing 1 or 3 or 5, because here we have to mention what they have given already the table. What we need to find is the number of times odd number appears, that means 1 or 3 or 5. And what is the observed frequencies they have given? For number of dice showing 1 or 3 or 5, 0 times means observed frequency 1. Similarly 1 time 10 given, 2 times here 24, 3 35, 4 18, 5 8. This is they have given the document. Now what we want here, first fit a binomial distribution to this data and calculate the expected frequencies. Expectation means here mean. Okay, first let us concentrate here. What is probability of getting 1 or 3 or 5? Normally in general case, see 1 means 1 by 6, even 3 also 1 by 6, even 5 also 1 by 6. So 1 by 6 plus 1 by 6 plus 1 by 6, only this possibility, right, for the die. Now 3 by 6, that means P equal to half, even Q also half. Now let X represent the number of times an odd number turning out. Let us discuss number of, see here they have already given odd number turning out, let it be X. So what is the probability function P of X? Equal to NCX P power X into Q power N minus X. But what is N here? N equal to what? N equal to 5, because 5 dice were thrown, right? Now continue with this. So what is the simplification part? 5cx 1 by 2 power x, 1 by 2 power 5 minus x. See 1 by 2 power x, 1 by 2 power minus x, so cancel, only remaining term is 1 by 2 power 5. That is nothing but 1 by 32 into 5cx. Now this is the binomial probability distribution function. Now let us discuss the next part. Since 5 dice were thrown 96 times, so what is the actual frequency? 96 into this function you have to consider. Let it be fx equal to 96 into this px. Now when x equal to 0, what you will get? When x equal to 1, what you will get? When x equal to 2, what you will get? You have to check and you have to mark it in table directly. So what is f of x here? 96 into 1 by 2 power 5 into 5cx, that is 3 into 5cx is the standard one. Now when x equal to 0, what you will get? See 3 into 5c 0, 3. Next when x equal to 1, you will get 3 into 5c1, that is 3 into 5 equal to 15. Next f of 2, 3 into 5c2 equal to 3 into 10, that is 30. For x equal to 3, f of 3 which is equal to 3 into 5c3 which is equal to 3 into 10 which is equal to 30. Next f of 4 equal to what? 3 into 5c4 equal to 3 into 5 equal to 15. Next f of 5 equal to 3 into 5c5 equal to 3 into 1 which is equal to 3. So what are the number of frequency, expected frequency here? 3, 15, 30, 30, 15, 3. You have to write at the end, or you can mark it in table also, it is left to you. Okay. Now it is known that among the 10 telephone lines available in an office, the chance that any telephone is busy at an instant of time is 0.2. Find the probability that, first case, exactly 3 lines are busy. Second one, what is the most probable number of busy lines and compute its probability. And what is the probability that all the telephone lines are busy. See here you have to choose, let P be the probability that any telephone is busy at any instant of time. Now what is given here? Probability P equal to 0.2. Since P equal to 0.2 they have given, what is Q? 1 minus 0.2, that is 0.8. And how many telephone lines? n equal to 10. Since 10 telephone lines available in an office, so n equal to 10. So what is the probability function p of x, which is equal to 10 cx into 0.2 power x into 0.8 power 10 minus x, right? Now first what is given? Exactly 3 lines are busy. Just put x equal to 3. Okay, so what you will get here? First one, probability that exactly 3 lines are busy, that is P of 3, which is equal to 10C3 into 0.2 power 3 into 0.8 power 7, that is 0.2013. Next, the most probable number of busy lines equal to what? NP, mu equal to NP, right? So you will get 2. So what is probability of P of 2? 10C2 0.2 power 2 into 0.8 power 8, which is equal to 0.3020. And last one, the probability that all lines are busy. All lines, how many lines? Total 10 lines. All 10 lines are busy, that is P of 10 equal to what? 10C10 0.2 power 10. If you calculate 0.0000, it is very negligible. So you can write 0, right? So this is the, see, always you have to remember probability, always value lies between 0 to 1. See here. This is mean. Don't confuse with this. This is 0.30020. Now last problem under binomial distribution. Fit a binomial distribution for the following data and obtain the expected frequencies. Okay, x given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and f given 6, 20, 28, 12, 8, 6, 0, 0, 0, 0. Now first obtain mu, because we need to find my binomial distribution, right? Now they have given x and f, so you have to find mu. What is mean? Mean equal to, if frequency given, then mean can be find out with the help of summation fx by summation f. What is summation fx? 0 into 6 plus 1 into 20 plus 2 into 28 plus 3 into 12 plus 4 into 8 plus 5 into 6 plus like this. This into 0, 0 like this. Divided by sum of f, you will get 174 by 80, that is 2.175. So what is mu? Mu equal to NP. NP equal to 2.175. Now, since x takes the value 0, right? And n takes the value what? N equal to total 10. So what is P? We know here NP equal to 2.175. N is known quantity 10. So 10P equal to 2.175. So what is P? 0.2175. And what is Q? 1 minus P, that is 0.7825. So what is probability function P of x? 10cx, say ncx, p power x, q power n minus x is the formula, right? Now start one by one. When x equal to 0, what you will get? P of x, right? When x equal to 1, what you will get? X equal to 2, what you will get? Similarly, up to x equal to here, what? 10 given, right? When here x equal to 2, x equal to 3, x equal to 4, same one, but what is probability function? Just replace in the previous formula. Say this is your formula. Instead of x, replace 0, then 1, then 2, then 3, like that. So what you will get? Here you have to mention. Okay, now 0.0861 here for this 2.2392, here 0.2992, like this. If you calculate till then, you will get the, okay. So this is the final answer for the probability distribution. Okay, now here it ends with the binomial distribution. Okay, please work out with the remaining all sums under this concept. Okay, thank you.